sharing it to you. Okay, so this is another question regarding dimensional analysis. Okay, so this question is a basic question. We don't have too many wordings inside, straight to the point. Okay, so we will start. So this is chapter 5, dimensional analysis. This should be another tutorial on answering dimensional analysis question. The wall shear stress tau. Okay, so shear stress over here tau in a boundary layer depends on the distance from the leading edge to the body. Okay, so depends on, it means tau over here is a dependent variable. Okay, in a boundary layer depends on the distance from the leading edge of the body x. Okay, distance and then the density rho, dynamic viscosity mu, and the free stream velocity v using the method of repeating variables and the Buckingham pi theorem. Determine an expression of wall shear stress tau in dimensionless form. Take x, rho, and v as the repeating variables, and unit for shear stress is Newton meter -2. Right? So what you need to do first is, as usual, number one, we need to list all the variables that you have. So number one, list all variables. Okay, in a test or while doing examples, you don't have to write down list all variables and all the information here. You just need to write down the calculation. Okay, this is done in order for you to get the idea what we are doing right now. So list all variable first, your dependent variable, tau, okay, or shear stress is equal to a function of, right, and then the others, which is leading edge x, rho, mu, and also v. All right. So here you will get n, which is the number of function or the number of parameters is equal to 1, 2, 3, 4, 5. So we have n equals to 5. Right. So check over here, 1, 2, 3, 4, 5. Right. So 5 of them. Number 2, list the MLTs for each variable. So this one is done by separating them like this, x, and then rho, and then mu, and then v. All right, so for tau over here is given Newton meter -2. Okay, when you have it in terms of Newton, you need to open it up so it's easier for you to do the MLT. So Newton is force. Okay, force. Okay, the unit is Newton. So it is mass times acceleration. So it is m. Acceleration is L t -2. Okay, so we use m L t -2. Right, and then x over here is distance. So distance is L, and then density. The unit is kg per meter cube. Kg per meter cube. So it is mass L -3. So m L -3. And then we have mu, which is dynamic viscosity. So the unit is equal to par dot s. So it is force divided by area, because par is pressure, force divided by area times second over here. times time over here. So you'll get mu. Force here we have here ml t negative 2. Area is L2 and then T1 here. So for mu, okay, so ML 1, negative 1. So ML negative 1, T negative 1. So for mu, it is ML negative 1, T negative 1. All right. And then we have V here, which is velocity. And velocity is LT negative 1. Okay, before we move further, do we have any problem getting this MLTs?
No, sir, like
Yeah. Okay. The complicated ones are mu and then also tau over here. Even though it's giving us the unit, but we need to know, for example, Newton is actually force. So force is mass time acceleration. So MLT is here. So I'm wrong here actually. We cannot use MLT negative 2. Okay, because we have M negative U over here, correct? So this is force. So tau over here should be MLT negative 2 and then M negative 2 here. Meter, it should be length. Okay, M here, meter should be length. So it is L negative 2. All right, so if you do the calculation, 1 minus 2, negative 1. So M1, L1, T negative 2. Right? So instead of MLT negative 2, it is M1, L negative 1, T negative 2. Okay? All right, so this is not hard actually, but it requires some simple calculation that sometimes can be confusing. But if you do it slowly and do it in a relaxed manner, you should be able to get the answer. Okay. So now we have all the MLTs. So we check on the MLTs. We know we have M. So we have L and we have T over here. So it means J is equal to 3. J, if you want to remember this, is based on the MLT. If you have M, L, and T in this MLT table over here, okay, so we have 3, okay, because we have M, L, and T. If you don't have any M, okay, at least at one of this part, if you don't have any M at all, we only have L and T, J should be 2, okay. And then to find out how many number of pi, so K equals to N minus J equals to 5 minus 3, so equals to 2. So we will have 2 pi's, 3 repeating variables, okay, and M number of variables. So 5 variables, 3 repeating variables, 2 pi's. 2 pi's mean 2 non-repeating variables. Alright, so that will be the beginning part of our calculation. Next, what we need to do is number 3, we list all pi terms. Okay, the pi terms that we have, right, should be based on repeating and non-repeating. The question already give us x, rho, and v is the repeating variables, or are the repeating variables. So x, rho, and v are repeating. So what does it mean is tau over here and also mu is a non-repeating variable. So what you do first, the first one, pi1, should be the dependent variable here. So it should be, all right. And then you have x a1, row b1, and then v c1. That will be pi1. And then pi2 should be the next one, mu. So x a2, row b2, v c2. Okay, so to remind you again, this on this side we have x row and v. Okay, so this is these are the repeating variables. Okay, and then we have here tau and mu. This is the non-repeating. Okay. All right. So, and then the next one will be this one, pi1 and pi2. This should be non-dimensional. Okay, it means the MLT is M0, L0, T0. Okay. Any question on this?
So, kalau kita dapat non-repeating tu tiga dari tiga lah saya.
For example, if you have 6 variables instead of 5, okay, the repeating is 3. So 6 minus 3, so we have 3 pi, for example. There is a time where the question for final exam, we have 7 variables, so 3 repeating variables. It means 7 minus 3, we have 4 pi. So we have 4, pi1, pi2, pi3, pi4, 4 non-repeating and 3 repeating. Okay. Right. Any other question?
No, sir.
No. All right. Anyone else? Any question? No. Okay. So once you get this ready, so we can solve this question by solve pi terms. Okay. So I solve it one by one. I'm using different color so that I'm not confused. So here we have pi1 is equal to tau, okay, x a1 row b1 v c1. Okay, so this is when you need to know that the MLT here is really important. So if you are wrong here, for example, just now I put m1 l1t negative 2 wrongly. It is just for force, but I did not include the m negative 2 at the back, so L length negative 2. So I might get into trouble because the answer will be definitely wrong, okay, from the beginning. Wait, let me check. One of you is providing question for me. Okay, for those who have problem with the internet, don't worry. I'm doing a recording, so I'm giving the recording to you. Okay. So let's continue. Right. So solve pi term. So we're gonna do the pi term one by one. So we do pi1 first. Okay. So pi1, this will become. Sorry. I need to change the color back. Okay, pi1. So this will become m0, l0, t0 equals to this one based on the MLT that you have. m1, l1, l negative 1, t negative 2. And then here x should be l1, a1. Rho should be M1, L negative 3, B1. And then we have V, L1, T negative 1, C1. Okay, I need you guys to make sure that anything with a power of 1, please put the 1 on top so it's easier for you to do the calculation. Okay, so if not, you might get confused if you don't have the 1 on top. All right, make sure you put it there. Okay, so first we do M. So first here, 0 equals to 1. And then another 1 here. 1 times B1 should be plus B1. So we don't have any other M, so it becomes B1 equals to negative 1. Right, so L, so here is 0 minus 1, okay, so equals to negative 1. And then we have another L here, plus A1. Then we have another L here, minus 3B1. Another L here, plus C1. Okay, so once again, this is an unknown, right? So we leave it that way. So T here, so T is equal to 0, equals to negative 2, and then minus C1. So C1 is equal to negative 2. So when you get this, we can fill in this equation here. So 0 equals to negative 1 plus A1 minus 3 times negative 1 plus negative 2. Right, so equals to negative 1 plus A1 plus 3 minus 2. So 3 minus 2 is 1. 1 minus 1 is 0. Correct? So 3 minus 2 is 1. And then minus 1 is 0. So A1 is equal to 0. Okay, so the answer will be pi 1 equals to tau x to the power of 0, rho to the power of negative 1, v to the power of negative 2. Okay, so pi 1 is equal to tau over rho v square. Okay, so that will be the answer for pi 1. Once again, any question?
No, sir.
No, sir.
Okay, no. Right, so we solve for one question over here, and then we go for another one. Okay, and then we solve for pi 2. So pi 2 is equal to mu. What do we have here just now? X A2, and then rho B2, and then V C2. Okay, so solve this. Pi 2 is M0, L0, T0 equals to mu1, M1, L negative 1, T negative 1. Is it correct? 1, L negative 1, T negative 1. Okay. And then here we have X, L1, A2, and then M1, L negative 3, B2, and then L1, T negative 1, C2. Okay, so, all right. And then to solve this, so for M, 0 equals to 1 plus B2. So B2 equals to negative 1. For L, it should be 0 equals to negative 1 plus A2 minus 3B2 minus, plus C2. Okay. All right. And then we have T 0 equals to -1 minus C2. So C2 is equal to -1. Alright. So -1 minus C2. Alright. So then we fill up this answer. So it is -1, 0 equals -1 plus A2 minus 3 times -1 plus -1. So we have 0 equals to -1 plus A2 plus 3 minus 1. 3 minus 1 is 2. 2 minus 1 is 1. So A2 equals to 1, -1. Okay. Alright. So we finish up. We get pi 2. Okay. So pi 2 is equal to mu and then x to the power of -1, rho to the power of -1, v to the power of -1. Okay, so we have pi 2 equals to mu x rho v. Okay, so we solve the second equation. Right, so the last thing to do is we need to collectively put everything in one equation. So pi 1 should equal to the function of, because we only have 2 pi, so pi 2. If we have more, we have comma, pi 3, comma, pi 4, comma, pi 5 and above. Okay, so we just fill in the numbers that we get before. So pi 1 is tau rho v square. So tau rho v square equals to the function of pi 2 mu x rho v. So tau is equal to, so we bring it up here, rho v square, function of mu x rho v. So this will be the final answer for this question. Okay, so if we can see from the first page, if we have only five amount of parameter or variables, and then we already have 3 repeating variables, we only have 2 pi's. So we don't have to solve a lot of pi terms. So we have pi 1 and pi 2. So the answer will be in terms of pi 1 equals to the function of pi 2. Okay. Make sure if you get this answer here, this is not the end of the answer. You need to bring anything below tau to the top so that, or bring it to the right side of the equation so that we will finish out with tau at the end here, right? And then you will get full marks if you do it this way.